Hello children, in today's class we will have one short video on reflection of light. That is, we are going to cover all topics, that is unit A, unit B, unit C, all concepts of reflection of light in this one video. Children, if you can watch this complete video, I am damn sure that you will, you are able to do the all types of questions in examinations. It might be a term exams, it might be a annual examinations. Children, once again let us see what are the main topics which we are going to cover in this one short video. Okay, look at here. First children, in this unit A, reflection of light in a unit A, first we will discuss what is a reflection and types of reflection. There only we will see characteristics of the image formed by plane mirror. So these are the main topics in a unit A. And in a unit B children, what is the number of images formed by two plane mirrors if they are inclined, and even we discuss the applications of what we can say plane mirror. So these are the important topics in a unit B. And a unit C children is very important. It is not only important for your academic examinations but also for competitive examinations, in which we will be discussing about the spherical mirrors. Especially we discuss the ray diagrams, that is image formed by a concave mirror, image formed by a convex mirror, especially sign convention children. This sign convention is very important in order to solve the numericals based on spherical mirrors. And finally, we discuss the applications of concave mirror and a convex mirror. Children, these are the most important topics from this chapter, reflection of light. So children, first we will see what actually reflection of light. So before that children, before going to understand the concept of reflection children, just look at here. Let us say here is a small ball. Okay, fine. Children, if this small ball, if I will throw towards a what you can say board, what happens? Look at here. It is thrown. Oh my God, what happened? It is coming back. Is it penetrating through the board? No, it is not happening like that. Children, similarly, when light strikes any surface, what happens? It bounces back. This phenomena of light only we can call it as a reflection of light. Let me write here, reflection of light. So reflection. So children, what happens? Similar to this ball, how when a ball is thrown towards the wall, how it is bouncing back. Similarly, when light strikes any surfaces, it might be a smooth surface, it might be a rough surface. What happens? It bounces back into the same medium. So children, in examination also, these keywords are very important, like a bouncing, it's a striking the surface. These are very important. So you can look at the definition even on the board also. Okay children, these are very important. In exam they may ask you define reflection of light. So you have to write this definition. Fine children. Now we see the types of reflection. Children, here we have two types of reflection, and the point is that on what base we are going to what we can say discuss the types of reflection. Children, it depends on whether light strikes a smooth surface or rough surface. Children, depends on that we have actually regular reflection, and one more thing which we have is irregular reflection. We have irregular reflection. Children, examination point of view, they will ask you what are the types of reflection, explain with a diagram. It's very important. First of all children, when this regular reflection takes place, the children, when light strikes smooth surfaces, it's very important. So regular reflection takes place when light strikes smooth surfaces such as mirrors. Okay, whereas irregular reflection takes place when light strikes rough surfaces such as wall, such as earth surface. You can take a paper. Actually, in fact, this irregular reflection is very important, which enables us to see the things which are around us actually. So very important. So children, look at here. So let us take here is smooth surface. Here is a smooth surface. Children, find the difference. Very important. Let us take here. Let us take here is a parallel beam of light. Children, a parallel beam of light is striking the smooth surface. Means you can see that here all incident rays are parallel to each other, and after reflection what happens? Look at here. After reflection, this is what actually they are going to, yes, means even in a reflected beam of light also children, the light rays are parallel to each other. Such a reflection we can call it as a regular reflection, which means what? Before reflection and after reflection, light rays are parallel to each other. So practically, let us speak, actually 100% reflection won't take place. So the point where it is instanting, there some amount of light gets absorbed, some amount of light may get transmitted. Okay, na? So 100% light won't get reflected. In ideal conditions only, 100% light will get reflected. That is our assumption. Okay, fine. Now look at the irregular reflection, children. For example, let us take it is rough surface. It is rough surface. Here, if you can see, children, here, let us take here parallel beam of light only. Here is parallel beam of light only. But after reflection, if you can notice, children, here after reflection, yes, here is light rays getting reflected like this. Here is one more light ray and where is third light ray. If you can see, children, here reflected light ray, what is happening? Are they parallel to each other? No, they are not parallel to each other. They are scattered in all directions. Such a reflection we can call it as a irregular reflection. Such a reflection we can call it irregular reflection. Children, whether it is a regular reflection or a irregular reflection, laws of reflection hold good. And you may get one doubt, sir, what are the laws of reflection? Yes, we will see that also. Okay, na? So this is what actually types of reflection. Children, this is also called as diffused light, which can be spread in all directions. In exam, they may ask you a question, what is that phenomena which enables us to see the things? What you should write? Reflection. Am I right? Mainly I can say it's a irregular reflection, not a regular reflection. It is purely about a irregular reflection. Okay, fine. Now children, so before going to discuss about the laws of reflection, all these things, once again let us see about mirror and the types one. It's very important. Children, as I said that, what is a mirror, children? What is a mirror? It is a mirror is a highly polished smooth surface which reflects whole light which is falling on it is called mirror. Children, only ideal mirror only can reflect 100% light. Otherwise, as I said that some amount of light gets absorbed, some amount of light get transmitted. So let us assume that it is a ideal mirror only. So children, here what are the types of mirror, children? Can you think? What are the types of the mirror? Do you have idea about the types of mirror? If so, just you can comment your answer. What are the types of mirrors? Okay, chalo, let us see, children. So here we have two types of mirrors. One is a plane mirror, another one is spherical mirror. Another one is spherical mirror. So if my guess is right, many of you thought that it is a convex mirror and concave mirror. Okay, na? Yes, that is also correct only, but in a broad beginning stage we are seeing that. So there are two types of mirror, plane mirror and a spherical mirror. Then what is a plane mirror? What is a spherical mirror? What makes the difference? Children, plane mirror, if you can see, let us take this one. So one side is a silver, another side it can act like a reflecting surface. That is fine. But the thing is that if you can see here, the reflected surface, the reflecting surface is straight or plane. This reflecting surface is straight, children. It's very, very, very important. It is straight or plane. The mirror whose reflecting surface is a straight or a plane is called plane mirror. Then what about spherical mirror, children? Yes, you can guess. So in this spherical mirror, reflecting surface is a matter here, children. Reflecting surface. This reflecting surface is going to be a curved. Children. So the mirror whose reflecting surface is a curve is called spherical mirror. Of course, here again we have two types. Am I right? So this is going to be a convex mirror and this is going to be a concave mirror. Anyhow, this we will discuss in detail. Okay, na? In detail we discuss what are spherical mirrors, what is a convex mirror, what is a concave mirror. Just here you should have an idea. Okay, children, what is a mirror? It is a smooth and highly polished surface which can reflect the whole light which is falling on it. Am I right? So there are two types of mirrors, plane mirror and spherical mirror. What is a plane mirror? See, on what base we are classifying? Based on the reflecting surface. Okay, the mirror whose reflecting surface is a straight or a plane is called plane mirror. What are spherical mirrors, children? The mirror whose reflecting surface is a curved is called actually spherical mirrors. Am I clear? Fine. Now children, now we see how reflection is going to take place on a plane mirror and what are the characteristics of the image formed by a plane mirror. Children, examination point of view, this is very important. Very important. So we may have conceptual questions like definitions, and we may have application questions, and we will have even numericals also. So we will cover each and every important point. Children, it might be a one short video, but we are not going to leave not even one point also. We will cover each and every important point from this chapter, so that you do the best in your examination from this chapter. Okay, fine. Now we will see, children, how reflection will take place on plane mirror. So let us write here reflection on plane mirror. First we will see reflection on plane mirror, children. So here some terms are very important. With that only we are going to get a good command on the concept. Okay, children, let us see. Children, this is how we can represent. We can represent plane mirror. This is very important. One side is silver, so that other side it acts like a reflecting surface. So children, here let M dash is a plane mirror. Okay, now fine. And children, the light ray which is coming towards the mirror is called incident ray. It's very important. The light ray which is coming towards the plane mirror is called actually incident ray, and the point where it is incidenting is called point of incidence. And children, the perpendicular line which is drawn at the point of incidence is called normal. And children, if you can see here, there will be angle between normal and incident ray. Children, the angle between normal and incident ray is called angle of incidence. Okay, fine. And what is the nature of the mirror? When light incidents, it gets reflected. Okay, fine, children. So this is reflected ray. Children, how to define reflected ray? The light ray which is moving away from the mirror after reflection is called reflected ray. Let us name it as a RS. Children, the angle between the normal and reflected ray is called angle of reflection. Children, these are the important terms. So here, what is PQ? PQ is incident ray. What is O? Point of incidence. What is ON? Normal. What is RS? Reflected light ray. So the examination point of view, they may ask you to define what is the angle of incidence, what is the angle of reflection. Children, what is the angle of incidence? The angle between normal and incident ray is called angle of reflection. What is So what is the angle of incidence? The angle between normal and incident ray is called angle of incidence. What about angle of reflection? The angle between normal and reflected ray is called angle of reflection. Fine, children. Now we see a laws of reflection. Children, according to first law of reflection, this angle PON must be equal to the angle SON. That is what angle PON is called. What, children? It is the angle of incidence. Means what here? Angle of incidence is always equal to the angle of reflection. Children, it's very important. You may get one doubt, sir, what happens when light incidents on rough surface? Children, whatever may be the nature of the surface, either it is rough surface or smooth surface, always angle of incidence is equal to the angle of reflection. Now, second law of reflection. Children, what is PO? Incident ray. PQ is incident ray. RS, reflected ray. ON, normal drawn. Children, here it's very important thing that incident ray, reflected ray and normal drawn all will be lying in the same plane at a point of incidence. These are the two laws of reflection. Children, I repeat, angle of incidence is always equal to the angle of reflection. Angle of incidence is always equal to angle of reflection, and incident ray, reflected ray, normal drawn all will be lying in the same plane at a point of incidence. Now children, then based on this in exam, how the question will be asked? Children, it's very important. Now let us see one example. It's like a numerical oriented, but it's not a numerical. Okay, children, please note down. So, children, in exam, they may give you like this. This angle is given as, for example, the 40 degrees. Now, they will ask us to calculate the angle of reflection, and even they will ask us to complete the diagram. So, many students blindly, they will write angle of reflection as 40 degrees. Children, do you think that angle of reflection is 40 degrees? You think? Come on, children. What is the angle of reflection? Is it 40 degrees? Yes or no? Is it 40 degrees or not? If it is yes, why it is yes? If it is no, then what is the correct angle of reflection value? You must comment. Okay? Done? Got it? Yes. Look at here, children. Actually, the angle between incident ray and normal is called actually angle of incidence. So this 40 is not angle of incidence, it is a glancing angle of incidence, the angle between incident ray and the plane of the surface. There is a surface of the mirror. So then how can we do it? Children, look at here. This total is 90 degrees. So can I write like this? Angle I plus 40 degrees is equal to 90 degrees? Yes, obviously. So then angle of incidence is equal to how much? 90 minus 40. This is going to be 50 degrees. Children, it is not 40 degrees. It is 50 degrees. So this is what, children? 50 degrees. Then as angle of incidence is 50 degrees, what will be the angle of reflection? Yes, children. According to first law of reflection, angle of incidence is equal to the angle of reflection, which means what? The light ray gets reflected such a way that angle of reflection also, 50 degrees only, not 40. It is a 50 degrees. Children, this is a one type of question which we can expect based on the laws of reflection. So children, now we see the second question, how the question can be asked. Children, here is a plane mirror. Children, so they may ask a question like this. How? If light is striking the mirror normally, if light strikes normal to the surface of the plane mirror, what will be the angle of incidence and what will be the angle of reflection, and complete the diagram. After reflection, we have to complete the diagram and we have to show. So I repeat. So light ray is striking like this. Children, can you guess what will be the angle of incidence and what will be the angle of reflection? Just pause the video, think a while, children. It is needed. You have to think. Come on, start thinking. Got it? Then just comment your answer and cross check. What is the angle of incidence? Children, I think, got it? Fine. Many children, they may get confused. They may think that, sir, it is perpendicular means 90. They may write angle of incidence as 90 degrees. No, it is wrong. It is not 90 degrees. Children, let us recall once again. What is the angle of incidence? Children, so the angle between normal and incident ray is called angle of incidence. But in this case, it is a normal and light ray also coming along the normal only. So there is no angle only, which means what here? The angle of incidence is 0 degrees. Then what about angle of reflection? Children, this we can tell in two ways. By following the laws of reflection, as angle of incidence is 0 degrees, angle of reflection is 0 degrees. Okay, fine. Conceptually, how? Practically, if you can think, children, if any light ray is striking normal to the surface of the plane mirror, children, its path is retraced. What? The light ray will go like this only. What? The reflected light ray also travel along the normal. So, children, angle of reflection also here 0 degrees. So, children, so these are the two important questions which can be asked based on the laws of reflection. Now, children, we will see what are the characteristics of the image formed by plane mirror. Children, there we can see here two cases. So here image formation by a plane mirror. We can see image formation by plane mirror. Children, here first we will see for a point object, then we will see extended object. So children, here first we see for a point object. So how the image is going to formed when point object is placed in front of a plane mirror. Children, so let us take, here is plane mirror, here is plane mirror, let us name it as M dash. So let us say this is the point object O, this is a point object O. Children, in order to make a ray diagrams, actually the minimum number of light rays required are 2. Okay, fine. So from here, let me take one light ray. Children, this is first incident ray, and let us take one more incident ray. This is second incident ray. Children, you just notice this first incident ray, it is incidenting normal to the surface. And just we have seen, if any light ray is incidenting normal to the plane mirror, what happened? Its path is retraced, means it bounces back in the same path. So this is a first, it is incident ray and one dash, just for sake of convenience I am telling you, this what actually first reflected ray. Okay children, but this first light ray, okay, it's going like this, let us say. So children, what about a second reflected ray? Look at here. This light ray, by obeying the laws of reflection, children, it gets reflected like this. This is 2 dash. So this dash numbers will represent actually reflected rays, let us say. Children, the first reflected ray, second reflected ray. Children, in order to get image, actually here what actually image, children? The point where what we can say, the point where reflected light rays will meet or they appear to meet is called actually image. Children, if you can see here, is there any chance for these two reflected light rays to meet? No chance, they cannot meet. Children, whenever the reflected light rays are not meeting, we have to extend back. I mean what? So this has extend this light ray back. So this is a first reflecting surface extended back, and here is a second reflected light ray extended back. So this is a point where image is formed. Image is formed. So one very important thing here. If the light rays are meeting after reflection, then we will get a real image. If a light rays are not meeting after reflection, they are appearing to meet when we produce them backward direction. In result, we get virtual image. Children, can you guess here what type of image is it? Are the light rays meeting after reflection? No, they are not meeting. They are appearing to meet, which means what? It is a virtual image only. It's a virtual image only. And children, the distance between object and a mirror is called object distance, and the distance between mirror and image is called image distance. It's very important. It is a very important. So it is proved experimentally that the object distance is always equal to the image distance, which means what? If you are standing in front of a mirror 10 meters, then your image is found behind the mirror at a 10 meters distance only. So children, this is how actually image of the point object is obtained. So in examination, they may ask you to make a ray diagram for a point object. Then you have to make like this. Now children, second one is, let us see for extended object. Let us see how the image is going to form for a extended object. Let us see for a extended object. So here children, here is, let us take, here is a plane mirror. So let this, let us say AB. AB is an extended object. So let us draw incident rays. Let us say this is first incident ray and this is second incident ray. It is second incident ray. Okay. Let us take, here is two more light rays. This is third incident ray and here is fourth incident ray. Okay na? Children, here 4 light rays which we have taken in order to obtain the image. Children, first let us concentrate on first and second light rays. These are incidenting normal to the plane mirror. Then what happens? Their path is retraced. So children, this is 1 dash and this is 2 dash. So their path is retraced. What about 3 and 4th light rays, children? By obeying the laws of reflection, with whatever the angle they are incidenting, with the same angle they get reflected. Let us see here. they get reflected. So children, this is how actually light ray get reflected. This is 3 dash means what? Reflected ray of third light ray. Okay, fine. And here is this what children? 4 dash. That is what? It is a reflected light ray of fourth one. So it's very it's a very comfortable to us to understand. Otherwise, putting 2 dash is not at all mandatory. Children, here also these reflected light rays are not meeting. Then what we have to do? We have to extend back. So children, so this light ray is extended back and this light ray is extended back like this. Okay, and this second light ray is extended back and third light ray also extended back like this. Fine. So this is the points where the light rays are meeting, and in between these only we get A dash, B dash. That is what children? It's the image of the extended object. Image of the extended object. Children, let H0 be the height of the object and here Hi be the height of the image. Height of the image. And here this is object distance and here is image distance. Children, I repeat once, it's very important. What is the nature of the image formed by a plane mirror? Children, either it is a point object or extended object. Always it gives virtual image. What is a virtual image, children? It's very important. What is a virtual image? The image which is obtained not because of actual meeting of reflected light rays. They are not meeting, but when they are extended back, they appear to meet. That image is called actually virtual image. So in examination, they may ask you a question. What is the nature of the image formed by plane mirror? It is children virtual image. Okay, now fine. Now let us write the characteristics. First one, children, it is virtual, comma, erect. And the second point is that children, it's very important. The image distance is always equal to the object distance. Image distance is always equal to the object distance. And here third one, children, very important. Image height is always equal to the object height. Image height is always equal to object height. And children, here one more phenomena which we have to discuss. That is, look at here. For example, here you can imagine a person. Okay, it is 2 hands, 2 legs. Okay, and this is what actually where the person's image is formed, let us say. Yes, image is formed here. For example, if it is a left hand and it is a right hand, let us say, then here it will be right hand and left hand, children. I think you might have noticed what happens, children, if you can stand in front of a mirror, when you can try to just shake your right hand, it appears as if you are shaking a left hand, which means what? Right appears as a left and the left appears as a right. This phenomenon only we can call it as a lateral inversion. Children, it's very important. Where I can write? Yes. Let me put here. This is lateral inversion. Very important. Lateral inversion. And here in examination point of view, they may ask you based on the alphabets also. So look at here, for example. So which alphabets can show, which alphabets do not show the lateral inversion? They may ask you a question. For example, children, let us take a P. This P appears like this. Yes, and let us take A. A appears like A only. So this is showing lateral inversion. Here it is not shown lateral inversion. Which means what here? The fourth characteristics of the image formed by a plane mirror is what? The image is laterally inverted. So image is laterally inverted. Image is laterally inverted. It's very important. Lateral inversion. Lateral inversion. Let us write directly. Lateral inversion. So children, these are the characteristics of the image formed by a plane mirror. So image is virtual erect. Image distance is always equal to object distance. Image height is always equal to object height. And image will mean this plane mirror will show it's a lateral inversion, which means what here? Left appears as a right and right appears as a left. And children, based on this, how the question can be asked based on these characteristics, very important, which we are going to discuss. Children, have you copied this? Just pause the video, copy it. Done? Can you erase? Yes. So children, now let us see how the question can be asked based on this. How the question can be asked. They may ask a question like this. In front of a plane mirror, some insect Children, it is not R, let us say it is an insect only. So is sitting or standing or sleeping, whatever it may be, it is 2 meters distance. 2 meters distance. There are going to be two questions. What is the image distance? What is the image distance? First question. And what is the distance between insect and its image? Children, can you do it? Pause the video and do it and comment your answer. What is the image distance? And what is the distance between insect and its image? Got it? Now let us cross check. Children, as per the characteristics of the image formed by a plane mirror, if an object is placed at x distance in front of it, the image also formed behind the mirror at x distance only. Which means what? Here the image is formed here. Which means what here? 2 meters distance only. So the image is formed behind the plane mirror 2 meters distance. Now second question. What is the distance between insect and its image? That is 2 meter plus 2 meter. It is going to be a 4 meters. It is going to be a 4 meters. Okay children. So children, these are the questions which we can expect from this unit A of the reflection of light. Okay children, fine. Now, so till now we have a discussion with only one plane mirror. Now let us see what happens children when two plane mirrors are taken and moreover which are inclined and how many number of images are formed. Children, it's very important. So what are the number of images formed when object is placed between inclined plane mirrors? So very important. Look at here children. So here let us take let us say one plane mirror and here is another plane mirror. Let us say another plane mirror such a way that they are inclined with an angle theta. Then what are the number of images formed? Children, it's a very important examination point of view. Definitely there will be a question based on this. Definitely there will be a question based on the finding the number of images when two plane mirrors are inclined each other. Children, here the number of images formed n is equal to, this is 360 by theta. 360 by theta. But children, here only many students will have a confusion. My advice is that children, if you can go to the textbook, especially of ICSE class 9th, definitely you may have a confusion. First watch this video, then you go through it, definitely you will get a clarity. Okay, fine. Children, as n is equal to 360 by theta means n can be a even number or n can be a odd number. Let us see here, it's very important. What happens if n is a even number children? If n is a even number children, if n is a even number, if n you will get as a even number, then children, very important, then total number of images can be n minus 1. This is very important. So example, children, whether they are symmetry or unsymmetry, then you may get a wonder, sir, what is the symmetry and unsymmetry? Let me show you. But before that, let me tell you one example. If theta is equal to 90 degrees, first you substitute in this. So n is equal to 360 by, it is 90, 360 by 90. This you will get a 4. Children, 4 is an even number. Then what we have to do? We have to do the 4 minus 1, that is 3. So children, if two plane mirrors are arranged perpendicular to each other, then the number of images formed are 3. And here I used symmetry and unsymmetry. What is that? Let us see children. Symmetry means, look at here. This is one plane mirror. Sorry. This is one more plane mirror. This is, for example, if the object is placed exactly at this point, the line which is bisecting this is. So this is 45 degrees and it is a 45 degrees. This is called symmetry. And an object can be placed like this also. Here is one plane mirror. Here is one more plane mirror. Object can be here also. So that, for example, this can be 30 degrees and this can be 60 degrees. Children, whether it is a symmetry or unsymmetry, whatever it may be, if you will get n as an even number, then what we have to do? We have to subtract by 1. And you may get a wonder, sir, why we should subtract? What is the reason? Children, here what happens, out of these 4 images formed, actually 4 images are formed. but out of 4, 2 images will get merged. 2 images will get merged. So, for example, 4 images are formed actually, but these 2 images will get merged. Now, you tell me 1, 2, 3. There are 3 images are formed. Okay, now fine. And what about if n is an odd number? What about if n is an odd number? So, let us take one example. If n is equal to, for example, theta is equal to 72 degrees children. If theta is equal to 72 degrees, that is n is equal to 360 by 72. 360 by 72. How much you will get? So, n is equal to 360 by, this will be 5. It is an odd number. Here also we have 2 cases children. So, here symmetry or unsymmetry. For example, let us take children, it is an asymmetry case. Let us take it is a asymmetry case first. Then we will see even symmetry case also. We can see even asymmetry and symmetry case also. Here children, for example, what is it? 72 degrees. So, for suppose this is one mirror, it is a one more mirror. So, exactly, not exactly, it's asymmetry. So, it can be like this. Let us say this is 32 degrees and this is 40 degrees. This is asymmetry case. Symmetry case means what here? Look at here. So, it is a one mirror and here is another mirror. So, object is placed here so that this angle is 36 degrees and this angle is a 36 degrees. Am I clear? Symmetry and unsymmetry. If it is asymmetry case children, the number of images will be n only, that is 5 only. There are no changes. But whereas if it is a symmetry case children, symmetry case, as I said that in a symmetry case what happens actually, the 2 images will get merged, which means what? Here the number of images are n minus 1. This is 5 minus 1. This will be 4. This will be 4. Children, I repeat here. So, here theta is the angle between the 2 plane mirrors, so that n is the number of images formed. Then to find the number of images, the formula is n is equal to 360 by theta. Children, this n can be an even number, it can be an odd number. If it is an even number children, either the symmetric case or asymmetric, you no need to think only. Directly you subtract by 1, that is n minus 1. 4 minus 1 you will give 3. But whereas if it is an odd number children, it might be asymmetry and it might be symmetry. With the odd number of images, if it is asymmetric case, the same number of images will retain. But if it is an odd number of images with a symmetry case, then what happens? So, only 4 images are formed actually. And more in examination point of view, you no need to get confused. You may get one question. Sir, do they give whether it is symmetry or asymmetry? Yes, sometimes they may give you, sometimes only. But maximum 99% this type of questions expected. If they will give this type of questions children, definitely they will mention in a bracket either it is symmetry or unsymmetry. I mean, they are very sure that the images are going to be odd number only. Then definitely they must give either symmetry or asymmetry case. Otherwise, it is highly impossible to do it. But not to worry, definitely this hint will be given asymmetry or symmetry. Okay, children, just you copy it. Now we will see. Acha, here one more important point. Here there are 3 number of images formed. Here might be 4 number, here 4 and here is 5. But what is the position of the image? Where these images are going to be formed? Very, very, very important. Children, look at here. This is a plane mirror. Okay, na? And here is, let us say, one more plane mirror are arranged. This is a point object, let us say the object O is placed. Now, children, try to connect this, the point where the mirrors are meeting and to this object. Let us say this is x, some distance will be there, right? Obviously, there will be a distance between the point of intersection mirror to the point where we have placed the object. Now, what we have to do, children, with this x as a radius, you imagine a circle. Means it might be like this. You imagine a circle, this as a radius. You can imagine a circle. Okay, na? Children, this distance as a radius, you imagine a circle. Now, children, either there are 3 images, 4 images or 5 images. All these images are formed on the circumference of the circle only. This is very, very, very important. Either there are 3 images or 4 images, 5 images, 6 images. whatever it may be, all these number of images are formed on the circumference of the circle only. Is that clear? Fine. And children, examination point of view, two cases are very important. In examination, they will ask us to find the number of images formed when the two plane mirrors are placed parallel to each other. Children, it's very important. Very much important. There are two cases are very important examination point of view. The first one is two plane mirrors are placed parallel to each other. So parallel to each other means what will be the angle between the two plane mirrors, children? This will be theta is equal to 0 degrees. Children, can you guess, can you calculate what are the number of images formed when two plane mirrors are arranged parallel to each other? Children, come on, try it. If theta is equal to 0 degrees, what are the number of images going to be? Just pause the video, try it. Children, it's very important. Trying is very important. Anyhow, we are going to have answer, correct answer, so that you can cross check. But initially, you have to try from your end. So if two plane mirrors are placed parallel to each other, what are the number of images formed? Pause the video and try it, and don't forget to comment your answer. Got it, children? Shall we do it? Yes, look at here. So we know that n is equal to, this is 360 by theta. So this will be 360 by 0 degrees. So this is going to be infinite number of images. Children, very important. If two plane mirrors are placed parallel to each other, then the number of images are going to be formed. Or how many, children? Infinite images. Children, in an examination point of view, they may ask you to draw the ray diagram also. You can just see the image. You can see the diagram on the board. This is what actually you have to draw if this question is asked. Okay, fine. And the second one is that if two plane mirrors are perpendicular to each other, perpendicular to each other. Just we have seen that. Let us check once again. If theta is equal to 90 degrees, so n is equal to 360 by theta, that is 360 by it is 90. So n is equal to 4. But children, 4 is an even number, so it is a -1. So the total number of images formed when two plane mirrors are placed perpendicular to each other are how many, children? There are 3 images are formed. And even, children, for this also it is asked. See, generally they won't give a priority for the ray diagrams, especially in this concept actually. Concave, convex, it will be given actually, but there might be a chances to ask you to show the number of images formed when two plane mirrors are arranged perpendicular to each other. That we have to show the diagram that you can see on a board, children. So this is a diagram. The two diagrams are very important. These are the two important questions which are very important examination point of view. What are the number of images if they are placed parallel to each other, and what are the number of images if they are arranged perpendicular to each other. Okay, children, fine. Now this is the time to see applications of a plane mirror. Children, what are the applications of plane mirror? So children, plane mirrors are used as a looking glass. I mean what? Many of us, we do, every day we can just look at a plane mirror and you can see and everything. For some persons, the day won't go without seeing their, face in a plane mirror. I mean, clear means what? Plane mirrors as used as a it's a looking mirror. First one. Second one, these are used in periscopes, and even these plane mirrors are used in kaleidoscope also. So these are the important applications of the plane mirrors. Okay, children. So this is a second concept. Now we are going to see what are spherical mirrors, types of spherical mirrors, convenient rays, and ray diagrams, and a sign convention. So very important. Okay, children, fine. Now we will see what is a spherical mirror, what are the types of spherical mirror, and how they are made. Look at here. So let us see the spherical mirror. Children, what is spherical mirror? Beginning of this class which we have discussed, beginning means just after some time we have discussed. Fine. Spherical mirror. Children, the mirrors whose reflecting surface is curved is called actually spherical mirror. Now how they are made? Let us see. Children, here let us imagine, let us assume what you can assume. You can imagine a glass hollow sphere. Children, we know the tennis ball. If it was made up of the transparent glass, how it would be? Of course, we are not going to play with that. Just imagine a situation. If that ball was made up of with a transparent glass, how it would be? Yes, it is a glass hollow sphere. Transparent glass of hollow sphere actually. So this is what actually. Now children, here let us make two cuts. Let us make two cuts. Now how many pieces which we got? 1, 2, 3. Now let us remove this third part, children. This is not required. This is not at all required. Okay, children, now first I will show you how the 3D figure of this mirror, this curved surfaces. Here we got two curved surfaces. Children, this is actually the curved surface are going to be. But for the sake of our convenience, we are not going to take a 3D curved surfaces. Rather, we can take simply curvatures. That is the 2D part we will take actually. So, these are the two curved surfaces which we got. Children, we had two scientific words are very, very important. This is actually outer surface, very, very important. It is outer surface. It is outer surface, and this is inner surface. This is what, children, it is a inner surface. Children, this outer surface only we can call it as a convex surface. It's very important. It's a convex surface. Whereas this inner surface is called concave surface. Is called concave surface. Children, based on either convex surface is silvered or concave surface is silvered, based on that only spherical mirrors are classified into two groups, two categories actually. It's a concave mirror and a convex mirror. Children, it is purely based on either inner side is silvered or outer side is silvered. Look at here, children. For suppose, children, here what happened here? Outer side is silvered. Outer side is silvered. Which means what? Then inner side will act like a reflecting surface. So this is reflecting surface, children. This is reflecting surface. This is reflecting surface. So children, the mirror, it's very, very important. If for example, in a particular this curved surface, the outer side is silvered. Outer side is silvered, so that inner side acts like a reflecting surface. Such a mirror is called, children, concave mirror. Very, very, very important. It's called concave mirror. For a concave mirror, outer side is silvered, so that inner side acts like a reflecting surface. If not, children, look at here. Here what is happening here? Inner side is silvered, so the outer side, that is the convex side, acts like a reflecting surface. Such a spherical mirror only we can call it as a convex mirror. We can call it as a convex mirror. Children, it's very, very important. For a concave mirror, outer side is silvered, so that inner side acts like a reflecting surface. Whereas for convex, it's a mirror, children. For this, inner side is silvered, so that outer side acts like a reflecting surface. Okay, children, fine. Now we see some terms related, children. These terms are very, very, very important. So now we'll see terms related to the mirror. Children, these terms are common for a convex mirror and concave mirror. Examination point of view, we may expect some definitions also from this. Children, let us see once again. So let us take concave mirror. Let us discuss the terms. Fine. Children, this is what type of mirror is it? It is a concave mirror. It is a concave mirror. Fine. Yeah, children, the very, 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 very important. The first term is, for example, children, this spherical mirror, previously, children, don't you think that it was a part of a glass hollow sphere? Yes, it was a part of a glass hollow sphere, and that glass hollow sphere has some center. This only we can call it as a center of curvature. So in exam, they may ask you to define the center of curvature. The center of a glass hollow sphere in which a spherical mirror was a part is called actually center of curvature. And children, at the same time, this spherical mirror also has some geometric center. the geometric center of the spherical mirror is called pole. Very important. What is a pole? The geometric center of the spherical mirror is called pole. Fine. And children, the line which is joining center of curvature and a pole is called principal axis. This is called what, children? It is called, it is a principal axis. Very important. Principal axis. What is the principal axis? It is an imaginary and infinite line which is passing through the center of curvature, and pole is called principal axis. And children, the distance between center of curvature and pole of the spherical mirror is called radius of curvature. Is called what? Radius of curvature. What is the radius of curvature? The distance between center of curvature and pole is called radius of curvature. And children, if you can see this point, let us say it's M, and let us say this point is M dash. So from here to here, it represents the diameter of the spherical mirror. The diameter of the spherical mirror means the effective part of the spherical mirror where reflection will take place is called actually aperture. Is called what? Aperture. Okay, fine. And especially in the case of concave mirror, children, if any light ray is coming parallel to the principal axis, after reflection, it has to pass through particular point on a principal axis. That point where reflected light rays will meet in the case of concave mirror is called focus. And the distance between focus and pole is called focal length. Fine. Children, let me repeat once again. It's a very important examination point of view. The center of glass halo sphere in which spherical mirror is a part is called center of curvature. What is a pole? The geometric center of the spherical mirror is called pole. And the effective diameter of the spherical mirror is called aperture. And children, the distance between center of curvature and pole is called radius of curvature. And what is the principal axis? An imaginary infinite line which is passing through the center of curvature and pole of the mirror is called actually principal axis. And one more very important thing, children, is the focus. What is the focus? After reflection, especially from a concave mirror, children, all light rays will meet at a common point and a principal axis is called focus. And the distance between focus and pole is called focal length. Children, how focal length and radius of curvature are related? It's very important examination point of view. Radius of curvature is double the focal length, or focal length is equal to half of the radius of curvature. Children, this is applicable for concave mirror and as well as convex mirror. Based on this also we can expect the numerical. So here focal length of the spherical mirror is given. If for example, if focal length of the spherical mirror is 20 centimeters, they may ask you to find the radius of curvature. That is, this will be 2 into 20. This is going to be 40 centimeter. It's going to be 40 centimeters. What about here? Radius of curvature might be given. For example, radius of curvature is 80 centimeters. They may ask us to calculate the focal length. So children, F is equal to either is R by 2, it is 80 by 2. This is going to be 40 centimeters. So children, these terms are as it is applicable for even convex mirror also, but small difference will be there. What is that? Children, if you can take here is convex mirror, everything is same. Look at it. That difference just we will see. This is a very important examination point of view. So as is going to be center of curvature, it is going to be pole. But children, for a convex mirror, when light ray is coming parallel to the principal axis and it gets reflection, reflected, it gets reflected, children. But this won't meet. This light ray appear as if it is coming from a particular point. This point only we can call it as a focus. So the main difference is that in the case of a concave mirror, after reflection, light rays will meet at this point. But whereas for convex mirror, light rays appear to meet means they appear as if they are coming from this point on a principal axis. This point is called actually focus. And one more important thing is that children here, that's what for concave mirror is said to be has a real focus, but a convex mirror is said to be has virtual focus. And one more difference you can notice for concave mirror, center of curvature, focal length and pole, or what we can say focus, all will be lying in front of it. But whereas for a convex mirror, especially radius of curvature, center of curvature and focus, they will be lying behind the mirror, children. These are very important. These are very important. So children, these are the terms related to the convex and the concave mirror. Children, before going to discuss the image formation, that is characteristics of the image formed by a either concave mirror or convex mirror, we need to learn the principal rays, that is convenient rays, in order to make a ray diagrams. Children, the minimum number of light rays required to make a ray diagram are 2. Okay, fine. Now let us see what are those convenient rays. We'll see now convenient rays for, we'll see for a convex and a concave. We'll see. First we'll see concave. Yeah, let us say C. Children, these are the convenient rays which we are going to consider in order to make a ray diagram either with a concave mirror or convex mirror. Look at children, for a concave mirror, if any light ray is coming parallel to the principal axis, after reflection, it must pass through the focus. It must pass through the focus. Whereas, if any light ray is passing through the focus, children, of a concave mirror, after reflection, it must move parallel to the principal axis. Whereas, if any light ray is incident at the pole of the concave mirror, with the same angle, it gets reflected. With the same angle theta, it gets reflected. And children, if any light ray is passing through the center of curvature and incidence, children, any light ray is passing through the center of curvature is nothing but the normal incidence for that mirror at that point. So this is normal incidence. Then what will happen? As we already learned, if any light ray is incidenting normal to the mirror, then what happens? Its path is retraced. So children, these are the 4 convenient rays out of which we can take 2 light rays in order to construct a ray diagram. Okay, fine. Now come to the convex mirror. If any light ray is coming parallel to the principal axis of convex mirror, children, after reflection, it gets diverged. But it appears as if it is coming from the focus. Okay, fine. And the light ray which is incidenting in a convex mirror, it appears as if it passes through the focus. But children, after reflection, what will happen? It moves parallel to the principal axis. And if any light ray is incidenting on the convex mirror at the pole, children, by obeying the laws of reflection, with the same angle, it gets reflected with the same angle theta only. And here, the light ray is incidenting on a convex mirror and appears as if it passes through a center of curvature. Is nothing but, children, normal incidence only. So whenever light incidents normal to the surface, children, what happens? Its path is retraced. So children, these are the important convenient rays which we are going to use in order to make ray diagrams. In examination also, they may ask a question. Mention any 2 convenient rays and explain with a diagram. Means, children, if they will ask you in general convenient rays, you can take any 2. But if they will mention specially, explain the convenient rays for concave mirror. So out of these 4, you have to take any 2. If they will ask for a convex mirror, out of these 4, you can take a 2. Okay, children, once again I am telling you, the minimum number of convenient rays required to make a ray diagram are how many, children? 2. Okay, just copy it. With the help of this, again, we are going to see how the ray diagrams, very important. Okay, fine. Just copy it, children. Done. It's very important. Just draw it. And children, one more very important thing is that whenever you are making ray diagrams, you have to use pencil and scale. It's very important. And one more very important thing is that, children, whenever you are making ray diagrams, make sure that focus is exactly in between pole and center of curvature so that we will get a nice ray diagrams. Okay, children, is it copied? Fine. Now we will see characteristics of the image formed by a plane mirror. Characteristics of the image formed by concave mirror. Children, with a concave mirror, here we have 6 cases. Okay, na? So it is concave mirror. Children, in each case, we have to see the characteristics. Children, what we have to notice? Actually, whenever we make a ray diagram, children, here 4 points are very, very important. What are the 4 points? The first point is where the object is placed. First point. Second point, where the image is formed. Third point, what is the nature of the image? I mean, it's the real image or virtual image. And the fourth point, it's a diminished or the same size or enlarged. Means we have to talk about the size also. So these are the 4 points which we have to notice. Okay, fine children. Let us see a case 1. Case 1, where the object. So whenever object is placed at infinity, children, we get parallel beam of light rays. And we know that, children, if any light ray is coming parallel to the principal axis, after reflection, what happens? They will pass through the focus. They will pass through the focus. Am I clear? Fine. Now we have to observe after reflection, either the light rays are meeting or not. If the light rays are meeting, it is a virtual image. If the light rays are not meeting, then if the light rays are meeting, it is the real image, children. If the light rays are not meeting, it is a virtual image. In this case, first of all, let us see where the light rays are meeting. If they are meeting at focus, which means what? Image is formed at focus. Image is formed at focus. First point. Second one, is it a real image or virtual image? After reflection, as the light rays are meeting, children, it is real image. Children, here by default all real images are inverted. All real images are inverted, and it is highly diminished image. It is highly diminished image. It is highly point size image will get. It's a highly diminished image. Children, especially this case of a concave mirror. Here what is happening? Light rays are converged. That's what concave mirror is also called as converging mirror. Children, in exam they may ask you to explain the converging action. Converging action, especially this is what actually converging action, very, very, very important. They may ask you to explain the converging action of the concave mirror, means you must make this ray diagram. So children, I repeat once again, what are the things which we have to notice? Object is placed at infinity, image is formed at focus, as the light rays are meeting, it is real, and it is inverted, and it's highly diminished. This is a case 1. This is a case 1. Okay, fine. Now let us say case 2. Let us say case 2, where object is placed beyond center of curvature AB. Now we have taken any 2 light rays, convenient rays, in which one is going to be a parallel to the principal axis. Okay, fine. So this will, what will happen here after reflection, children? It passes through a focus. It passes through a focus. This is fine. Okay. Another light ray which I am going to take is which is passing through a focus. Children, if any light ray is passing through the focus, after reflection, what will happen? It will move parallel to the principal axis. It will move parallel to the principal axis. Now you have to notice, are the light rays meeting after reflection? Yes, they are meeting. Where? This is a point. Means this is a point where image is going to be formed. It is A dash and it is a B dash. Okay, fine. The first point, where the image is formed, diminished image. So this is second case. Now children, let us see a third case. Let us see a third case where object is placed at C. Object is placed at C. So you should be careful with this case actually. So this will go like this. Now children, this is a point where the light rays are meeting. Look at here. So this is A dash and B dash. So children, what we can notice, this is a light ray which is coming like this. Children, the light ray which is passing parallel to principal axis after reflection will pass through the focus, and the second convenient ray which is passing through the focus after reflection will move parallel to principal axis, such a way that after reflection they are meeting at center of curvature. So it's very, very important. Means what? When the object is placed at the center of curvature of concave mirror, the image also formed at C only. At C only. It is same size as that of the object. Okay, fine. This is the third case. Now let us see a fourth case where object is placed between so what we can say, center of curvature and focus. This is, let us say A, B is the object. Children, we should take a 2 convenient rays in which one is passing parallel to the principal axis. Then what will happen after reflection? It passes through the focus. If any light ray is coming parallel to the principal axis, after reflection it has to pass through the focus. Fine. And let me take one light ray which is incidenting at the pole with some angle. Children, we know that with the same angle it gets reflected. The same angle it is going to be reflected. Yes. Now you extend these two light rays. Yes, like this. Children, now where the light rays are meeting? Look at here. So this is a point where light rays are meeting. So this is image position. So children, AB is the object and A dash, B dash is the image. Now you can look at here. It's very, very important. Children, where the image is formed? Image is formed beyond center of curvature. And the second one, is it real or virtual? Real image. Why? The light rays are meeting after reflection. So it is real and inverted. Third one is, it is enlarged image. It is enlarged image. Okay, children. So these are the 4 cases. Just you can try to copy it. The next 5th case also we will see that, children. So here 5th case, let us see. Where object is placed at focus. Children, object is placed at focus. After reflection it has to pass through the focus. Okay, through the focus. Let us take one more light ray which is incidenting at pole. Children, as per the rules of a convenient ray, if any light ray is incidenting at a pole with a certain angle, with the same angle it gets reflected. With the same angle it gets reflected. So children, here we obtain parallel light rays. We obtain parallel light rays. Children, parallel light rays are expected to meet at infinity. And one more common thing, if you can notice, the reflected light rays, if they are going below the principal axis, definitely they are going to meet, so that real image is formed. So here what are the characteristics which we should write? Here image is formed at infinity. Image is formed at infinity. And the second one is that, children, it's very, very important. Image is real because they are going to meet inverted or highly enlarged. Highly magnified or highly enlarged. Children, these are the 5 cases with a concave mirror. Let us see the conclusions, children. What are the conclusions with these 5 cases? Of course, 6th case, most wanted case is there. But before that, let us see the conclusions. Children, here what is happening? Initially, object is at infinity. Slowly, we are moving the object towards the mirror. But what is happening, children? First, image is formed at focus. Then between C and F and C. Then at C. Then beyond C and at infinity. Means what? As object is moved towards the mirror, image is going away from the mirror. I mean what? The motion of the object, the movement of the object and the image, both are in opposite direction. And one more thing, children, here first case and 5th case are vice versa. I mean what? Object is placed at infinity, image is formed at focus. But here, object is placed at focus, image is formed at infinity. Both are vice versa. And the second case, when the object is placed beyond C, image is formed between C and F. Whereas, when the object is placed between C and F, image is formed beyond C. And third case is very special, where the place where you are placing the object, that is at C, image also formed at C only. Okay, children, just you copy this and we see the 6th case, most wanted. Just copy it. Just copy this, very important. Okay, children, copy it. Fine. So, children, if you can notice, first case to 5th case, in all these cases, children, what is the nature of the image formed by the concave mirror? Either it is the first case or second case or third case or 4th or 5th. Children, the size of the image might be different, but the nature is same. That is, in the first 5 cases, concave mirror will give you real image. Now, let us see a 5th case, children. Sorry, 6th case, where object is placed, children, very important, between pole and focus. Between pole and focus. Let us see, children. Let us see A, B. Children, very important. Now let us take 2 convenient rays. Children, let us follow the same method. There is no difference in the following the method. Okay. the light ray which is moving parallel to the principal axis, after reflection it has to pass through the focus only. It has to pass through the focus. That's it. Now the second convenient ray I am taking, children, the second convenient ray which I am taking is, it is incident at a pole. Children, if any light ray is incident at a pole with a certain angle, then what happens? With the same angle it gets reflected. That is, with the same angle it gets reflected.
Same angle gets reflected. Children, you can look at, children, these are divergent light rays. These are divergent light rays. Children, divergent light rays can never meet. Can never meet. So children, if the light rays are not meeting after reflection, what we have to do? We have to extend back. So let us extend like this. Like this. This also extended back. So if you can see, this is a point where the light rays are appear to meet, and this is the image position. That is A dash and a B dash. A dash and B. So what is the specialty of this case, children? This is a case where concave mirror forms virtual image.
How can you say that it is a virtual image? Because the light rays are not meeting after reflection. So they are extended back so that they are appearing to meet. Okay, fine. Let us see the characteristics. First one is image is formed behind the mirror. First point, image is formed behind the mirror. Image is formed behind the mirror. Second one is, children, it is virtual. It is virtual and erect. Virtual and erect. The third one is, it is enlarged image. This is enlarged image. Okay, children, there is some certain special application with this case where concave mirror is used as a shaving mirror. Is used as a shaving mirror. So in exam they may ask you a question, why concave mirror is used as a shaving mirror? Because of these two reasons, virtual image and enlarged. Children, why can't we use plane mirror? Let us take a case, children. For example, let us take a person. For example, just you think that I have taken a neat shape, just you think that it is not neat shape, just think. And children, so sometimes what happens, in a plane mirror, if I can see, it seems to be everything is smooth. The moment when I can touch my skin, I may feel little bit hair particles, tiny hair on my skin, which may not be seen in a plane mirror. Why? The specialty of plane mirror is that it will give an equal size of the image. If air particle is very tiny, very tiny, even image also very tiny only. But children, in the place of plane mirror, if I can use a concave mirror, what is the specialty of the concave mirror when the object is placed between pole and focus? Though object is small, image will be enlarged. So now if I can see in a concave mirror, though it is a tiny hair on my skin, that can be seen enlarged in a concave mirror. That is the reason why concave mirror is preferred as a shaving mirror. It's very important. Okay, children, this is one of the important applications of concave mirror. Just copy this. Now we will see the image formation, that is the characteristics of the image formed by convex mirror and its application also. Just look at it. Now let us see a convex mirror. Children, with the convex mirror we have only two cases, not to worry. The first case, children, object is placed at infinity. Now we will see when the object is placed at infinity. Children, as we know that whatever with the mirror, children, if object is placed at infinity, so the very important thing is that we get parallel beam of light rays. We get parallel beam of light rays. Let us see here. So here two light rays are coming parallel to each other. Children, if any light ray is coming parallel to the principal axis of convex mirror, after reflection, it gets diverged. It gets diverged. Here also it gets diverged. So children, after reflection, these two light rays are not meeting. Then what we have to do? We have to extend back. Yes. So then where the light rays are appearing to meet, children, they are not meeting. Appearing to meet means virtual image is formed. So first position, where the image is formed, children, image is formed at focus. Second one, it is virtual. By default it is erect. By default it is erect. And children, it is highly diminished image. It is highly diminished image. It is highly diminished image. Highly diminished image. Fine children. Now let us take a second case children. Means object is placed here anywhere in between, anywhere between infinity and pole, that is a mirror. Whether you can place here, anywhere you can put where the image is going to be formed. Let us see children here. Let us take, this is the object AB. Now let us consider the two convenient rays. The one which is coming parallel to the principal axis. We know that if any light ray, it is coming parallel to the principal axis, after reflection it gets diverged. Okay na? Fine. Now second light ray, let us take the light ray which is incident at a pole with a certain angle, and after reflection it gets reflected with the same angle. Now here also children, these two light rays are not at all meeting. Then what we have to do? We have to extend back. So this light ray when extended back, so appear to meet at focus, and this light ray when you extend back, this is a point. So this is a point where the light rays are appearing to meet is actually what children? Image. So it is A dash and it is a B dash. Children, it's very important. Okay, and one more thing, don't forget that virtual image we will denote with a dotted line only. That makes the difference between virtual and real image whenever we are making a ray diagrams. So children, wherever you can place an object in between infinity and a pole children, always remember that, very important. Always image is formed behind the mirror. Image is formed behind the mirror, that too between pole and focus. Very near to the mirror. And the second thing is that it is always virtual and erect. The third one is that if you can see children, it is always diminished image. Children, this case of a convex mirror is used as a
rear view mirror. Very important. Why we only can prefer convex mirror? Why can't we use a plane mirror or concave mirror as a rear view mirror?
Children, you can use a plane mirror as a rear view mirror if you can use. What happens? Plane mirror gives same size of the object. I mean, what if one lorry is coming, the image also like a same size of lorry only. Even you can't see one lorry, how can you see other vehicles? So it's highly impossible to use plane mirror. What happens if you use a concave mirror in a sixth case? Concave mirror will give a virtual but enlarged image. Even small vehicle is coming also, in a concave mirror it appears enlarged. So obviously you cannot see, you cannot cover other objects also. But whereas convex mirror, because of two reasons children, in exam they may ask a question, why convex mirror preferred as a rear view mirror? Two reasons. First point is that it always gives virtual diminished image near the mirror. That's what on the vehicles, what is written, the objects in the mirror appears bit closer than they are actually. Okay, fine. And the second point is that the field of view of a convex mirror is more actually. Okay children, so because of these reasons only convex mirror is preferred as a rear view mirror. In exam they may ask you a question, explain or how can you say that convex mirror preferred as a rear view mirror. So you have to draw this ray diagram and you have to write these points. But two reasons I said, it gives virtual diminished image near the mirror. And the second one is the field of view is more. Its field of view is more. Because of these two reasons only convex mirror is preferred as a rear view mirror. Okay children, fine. Now children, we'll see the sign convention. It's very important, because the sign conventions are very important in order to solve the numericals based on the spherical mirrors. Okay, hope it is copied children. Is it done? Fine. Let us see a sign convention. Children, whenever we are measuring the distances, how to measure the distances, that is what actually we are going to discuss under this sign convention. So children, for this, to understand this, see, you can take any case of either concave or a convex mirror to understand it. So let me take one example children. Here is let us say concave mirror, the principal axis, pole, center of curvature, focus. For example children, here somewhere the object is placed, AB is the object is placed. So we know that here image is formed. This is the image is formed here. Children, the distance between object and mirror is a u, object distance, and the distance between image and pole we should take is actually v. And the object height is h naught, and the image height is hi. Image height is hi, and the distance between pole and focus is called actually focal length. Is called what actually focal length, children. Now children, the very important thing is that, so as object is placed here, even you can, if you want, you can make concave mirror this side also. It's not a matter. It's not that always object should be placed left side. You can, but in front of it only we must place actually. Children, whenever you can put object in front of a mirror, what happens? The light rays will move from the object towards the mirror to form an image. So first, let us take this is the incident ray direction. Children, this is how actually incident rays will come. Incident light rays will come. So this is a picture which we need to understand the sign convention. Children, the first important point here. So as per this rules of the sign convention, or that is pole is considered as the origin. The first point, pole is considered as the origin. And children, all measurements must be taken from the pole only. Why? Because pole is the origin. Very important. Very important, children. So here, all horizontal measurements must be taken from pole. For suppose children, now I want to measure the object distance. So object distance means what actually? This is the, from here to the object distance. You can take A to P or P to A. Children, you tell me, to measure the object distance U, should I take it as A to P or P to A? You may think, you may get one, sir, either it is A to P or P to A. Distance is same, sir. Distance is same, but direction is different. Children, as per the sign convention, horizontal measurements must be taken from the pole only. So you have to start from P and you have to move to A only. So P to A we must take. So object distance is what, children, here is PA. P to A we have to take. But while we are measuring, let us see the incident ray direction. If we are taking the measurements in the direction of incident ray, then it is a positive. Opposite direction is negative. Now let us see, children. I want to measure the object distance. So I should start from P and it should go to A. But as I am going to P to A, from P to A I am going. But incident ray is coming like this. Means what? Don't you think that we are moving opposite the direction? Yes. So the measurements taken opposite the incident ray are negative. So which means what here? Object distance is negative. Fine. Image distance. Image distance means you can take chance A dash B dash, sorry. A dash to P or P to A dash, both are same only. But as per the rules of sign convention, we must start from P only. So we should take P to A dash. So as we are taking P to A dash, so P to A dash means we are moving towards left, but incident is going right side. That is opposite only. So image distance also negative only. Image distance also negative only. Now I want to measure the focal length. It's very good. Focal length. So focal length FP. You can take F to P or P to F. But as per the sign convention, we must start from P only. We should take PF only. P to F we should take PF in the sense P to F. As we are measuring P to F, we are moving opposite the direction of incident ray. So focal length is negative. Which is very important. For a concave mirror, focal length is always negative. Always negative. And what about the height of the image and what the height of the object? Children, the measurements taken above the principal axis are positive, below the principal axis are negative. So as per that, object height is positive and image height is negative. Image height is negative. So children, so these are the sign convention rules. Even let us see for a convex mirror also once again. Here incident rays will always go to object towards the mirror. So this is the direction of incident ray. This is the direction of the incident ray. Now let us see, children. Now I want, so this is going to be object distance and this is going to be image distance. This is going to be a focal length. This is object height and this is going to be image height. This is going to be a image height. So now object height, from where we should measure? We should measure from pole only. That is, we should take P to A only. But as measuring from P to A, we are moving up. See, opposite direction incident ray. That is what incident ray is going like this, but we are moving in this direction. That is opposite direction. So it is a negative only. negative, very good. Image distance, P to A dash. Why P to A dash? Because P is origin. As we are measuring P to A dash, we are moving in the direction of incident ray. So, as per the rules, it is positive. The measurements taken in the direction of incident are positive only. Now, focal length P to F. We will start from P, we will measure to F, that is PF. And in order to measure, while we are measuring P to F, we are moving in the direction of incident ray. That is positive, which is very, very important. For a convex mirror, focal length is always negative, so always positive. Whereas for a concave mirror, the focal length is always negative. So very, very important. Okay, fine. And object distance, object height, it is above the principal axis, positive. Even image also found above the principal axis only. So image distance also positive only. So children, one common point which you can notice here, as it is a virtual image, for a virtual image distance is positive, image height is positive. But whereas for a real image distance is negative, image height is also negative. So these are the points which we have to note down. Children, these are the sign convention rules which are very important in order to solve the numericals. Without applying the sign convention rule, we cannot solve the numerical. If you can solve also, 100% you will get a wrong answer only. So we have to understand and we have to practice regarding the sign convention rules. Am I clear? Just copy it. Now these kind of sign convention plus some formulas are important to solve the numericals. So fine children. Now we'll see the first important formula is mirror formula. Children, very, 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 very important. It is mirror formula. It is mirror formula. Children, we know that U is a object distance. U is object distance, whereas V is image distance. Image distance, and F is a focal length. F is a focal length. Then mirror formula is a relation among these three terms only. That is 1 by F is equal to 1 by V plus 1 by U. So children, this is very, 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 very important mirror formula. Okay, this formula is used. See children, out of these three terms, two terms will be given. They will ask you to calculate the third term. So then we use this formula plus sign convention rules so that we can get the correct answer. Fine. Next children, we have linear magnification. We have linear magnification. Linear magnification will represent with a small m. Children, what is the linear magnification? Definition also very, very important, and what is its importance also we will see. Importance also we will see. Children, linear magnification is defined as the ratio between image height to the object height or image distance to the object distance. So I repeat once again children. Linear magnification is defined as the ratio between image height to the object height, that is hi by h naught. Also, it is defined as a ratio between image distance to the object distance. So, mathematically, m is equal to minus v by u. Minus v by u. So, we can combine these two. We can write this also. Image height by object height is equal to minus v by u. So, children, this is also very important to solve the numericals. Actually, what is the importance of knowing the linear magnification? Children, very, 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 very important. In exam also it can be asked. Children, if see, for example, so here image height is greater than the object height, then what happens? M can be greater than 1, which means what? M is greater than 1. Children, it is the enlarged image. Enlarged image. Okay. If image height is equal to the object height, then M value will be equal to 1, which is actually same size image is found. Okay. If image height is less than the object height, then what will happen children? M is less than 1, which means what here? Diminished image is found. Diminished image is found. Children, if you can notice, for a concave mirror these three are possible, but whereas for convex mirror only this is possible. While convex mirror always gives virtual image, always will give diminished image. Okay, fine. And by knowing the sign convention, Children, by knowing the value of the what we can say linear magnification, we can identify whether image is equal size or diminished or enlarged. But how to identify is a real image or virtual image? It's very important. So if m is positive, if m value is positive, it will be virtual image. It will be virtual image. If m is negative, then it is real image. Then it is a real image. Okay, children. So this is the importance of the linear magnification. So by knowing the value, we can talk about the size of the image. By knowing the sign of the linear magnification, we can talk about the nature of the image. Children, the last topic of the session is the applications of the spherical mirrors. Children, in exam, they may ask you just write the application of spherical mirrors, or sometimes they will specify, they will ask write the application of concave mirror or convex mirror. Children, what are the applications of concave mirror? You tell me. Children, here the first very important, concave mirror is used as a shaving mirror, and it also used in solar cookers. It is used by a dentist. It is used by a dentist, and it is also used as a reflector in the searchlights. So you can remember these 4 applications, so that is enough to write an examination. Then what about the application of convex mirror, children? So convex mirror is used as a rear view mirror, and it also used as a reflector. But where in the street lights it is used. Children, don't get confused. Concave mirror is used as a reflector, but where? In a searchlight. Convex mirror used as a reflector, where? In street lights. Very important. Okay. Children, the last one question I would like to ask is very important. Just try to think and just pause the video, and you can just comment your answer. The thing is that concave mirror gives virtual image in the 6th case. Convex mirror gives virtual image. Plane mirror also gives virtual image. My question is that what is the difference between the virtual images formed by these 3 mirrors? It's very important. So I repeat once again. 3 mirrors: plane mirror, convex mirror, concave mirror. These 3 mirrors will give virtual image. But what is the difference between the virtual image formed by plane mirror, concave mirror, convex mirror? Just you think and comment your answer. And children, so this is actually the topics almost we covered. For examination point of view, maximum I tried my level best to cover in one shot. Children, if you want in detail explanation of the light chapter, so in a description you can find the links where each and every topic is discussed in detail. If you want for a detailed discussion of the topics of the reflection of light, kindly go to the description where you can find the links through which you can go, so that you will get a more clarity. Okay children, thank you so much. All the very best.